Let's take a look at these examples. We're supposed to convert them to 2's complements. First, anytime you want to convert binary number to 2's complements, you have to find 1's complement. Okay, you have to invert every single bit. You have to find a complement of every single bit of the given number. So 1 is going to be 0, 1, 0, 0, 1, 1, 0, 1. Okay, the complement of 1 is equal to 0, complement of 0 is equal to 1. 1 is going to be converted to 0, 1 to 0, 0 to 1, and so on. This is my first complement, or 1's complement. Next, in order to find 2's complement, I'm supposed to add 1 to 1's complement. I have 0, 1, 0, 0, 1, 1, 0, 1, plus 1. 1 plus 1 is equal to, I'm supposed to write 0 and a carry of 1. 1 plus 0 gives me 1, and 1 has to come down, 0, 0, 1, 0. This is my 2's complement number. So this is the solution to my problem. Let's take a look at this one. We have to find the 1's complement first. We're supposed to convert every single bit to the complement. Supposed to simply write this is 1, 0, 1, 0, 1, 1, 1, 0. This is my 1's complement. In order to find 2's complement, I'm supposed to add 1 to 1's complement. And I have 1, 0, 1, 0, 1, 1, 1, 0, plus 1. 0 plus 1 gives me 1. I have to copy down 1, 1, 1, 0, 1, 0, 1. This is the 2's complement of my number, and this is the solution to my problem. Let's take a look at the third one. We're supposed to find the 1's complement, and I'm going to have 0, 1, 1, 1, 0, 1, 1, 0. This is my 1's complement. In order to find 2's complement, okay, this was 2's complement, I'm supposed to copy down 1's complement, 0, 1, 1, 1, 0, 1, 1, 0, and add 1 to 1's complement. I'm going to have 1, 1, 1, 0, 1, 1, 1, 0. And this is the solution to my problem.